So all right, hello everyone. My name is Viktor Stiskala, and I'm here mostly for networking. So you can find me on LinkedIn if you would like to talk later. I came here from Czech Republic, where I am a CTO at a company called Twisto, and we do a money app, which is an application for everyday finances. We are operating in Czech Republic and Poland as of now, and we do sort of an online credit card solution. And I'm originally a Python developer, and I obviously love Python a lot. And I play a lot of it with it in a free time, especially in the hardware segment. And I also design my custom PCBs because or printed circuit boards, because I really like the idea or the process of transforming electrical circuit into and a prototype like this into a physical device like that. And back at my home, I have a small herb garden on a balcony, and I wanted to monitor the moisture and the temperature in the pots in order to notify me in case that it's time to water the plants. So I was looking for a solution, and obviously there were two biggest challenges. One of them was that it has to be battery powered, because I don't have any electrical source on the balcony. And the second one is that it needs some weatherproof design and needs to fit into a small enclosure in order to be weatherproof. So when you look on the internet for the solutions, you find out probably the two most popular options. One of them is Raspberry Pi, which is a fully featured small computer running a Linux distribution, which is great. It can run Python, it can run almost anything, but it's very power intensive and therefore not suited for a battery powered operation. And the other option would be to use, the other most popular option would be to use an Arduino or any sort of microcontroller board that is using just your code, but they are mostly written in C. As I'm a Python developer, I was looking for other solutions, and especially some Python microcontroller units that I could use. And in my search, I've ran to a MicroPython, which is a Python flavor that can run on a specific board. And they have their own eShop, and you can buy pretty powerful boards that have Wi-Fi, Bluetooth, and all other peripheral devices that you can connect into them. But the problem is they're quite pricey, and they are a bit of an overkill for a solution like that. So I dig deeper, and I found out a really nice, neat solution, which is called NodeMCU. It's just a developer board based on ESP8266. It has great features for battery powered operations because it has a low power consumption. It has a deep sleep mode that you can use to conserve the battery power and run it for a long time. It has an onboard Wi-Fi, and it can serve both as an access point and as a client. And also it has a very compact size. And then you look on the internet and you find out that it's very cheap, and therefore it's one of the biggest advantages of this board. So it's my main board of choice for applications like that. And before I found out about it, I didn't even knew that I can run Python on a small device like that you can put into some small enclosure. And with a Lion battery or an AA-sized battery, it can run projects for about a year on a single charge, which is pretty cool. So I hope I got interested about the topic. Definitely check out the MicroPython website. Look at the other options and the boards they have available, and start something new, because creating sensors and projects is a really fun job. And I came up from creating small prototypes into simple PCBs in about a year. So it has a really nice learning curve, and it inspires me to create other projects. So thank you for your attention.
Thank you so much for sharing that. We'll quickly go to the next talk.
Hello, I'm Chris. I got my PhD in '92. same city, same country as somebody else from the Netherlands got his PhD. Also on a programming language, also starting with a P, not PyCon. So if you can find out what my language is called, I'll buy you a beer tonight. Guido 1, I'm actually a Python fan, and I've written a couple examples on my GitHub page. So I'll go there. I don't have enough time. I can fill the whole board with lots of demos, but I'll focus on one specifically, which is visualization of Python. So when I interviewed for Google, I was practicing sorting algorithms and all those things. And I didn't remember what the difference between bubble sort and quick sort and all of those things. So I started writing them. And here's an example of breadth first search. So what I did is I built a Python environment where you have the algorithm on the left. I'll make the font a little bit bigger. The algorithm is on the left, the visualization is on the bottom left, and then the picture is on the right. And you can go back in time, so you can scroll, and you can see on the left where the actual code was running. And on the right, you can see how breadth first search, actually, if you can see it, it's sort of like this wavy pattern at the bottom. If you go to depth first search, you will see vertical ones. So how does it work? The code gets actually shipped to an App Engine instance. It runs the Python there. It sets a breakpoint at every line using sysset trace, which is a cool thing about Python is you can do introspection of the execution. And in that, every time you stop, I basically render a frame, and that generates a picture. So there are quite a few visualizations here, 50 of them, whatever. I like this one a lot, which is drawing or calculating pi. So you see on the left is the algorithm to calculate pi, and at the bottom left it's calculating the visualization. And we do this by throwing 600 random needles on the board, and if they touch any of the lines, they become red. And if you divide the total by red, you get pi. Very close, not quite, but if I run it again, it probably gets closer. I probably need more needles. And this is a person, a mathematician called Buffon, who came up with the idea. So now it's very close, so let's keep this one. There are other ways of doing pi. Just take a look at my website, laffra.com. Go to GitHub. The source for the whole visualization is there as well. Thank you.
Thank you so much, Chris. Can we have the next? Hello?
All right. Wait, that's the, yeah, that way. Yes. This side. HDMI. Oops. Okay. So, hi guys. My name is Ken, and my day job is being a site reliability engineer at Big Bang. But that's not the topic right now. Question is, how many of you are from companies that are hiring right now? Okay, vast majority. How many are finding hiring easy? Yep, what I thought. So this is the Estonian main hiring portal. We can see that everybody is looking for IT guys, like on the top there, on the video, pretty much all those here. Okay, so we know that hiring IT is hard, but let's talk about another topic. My background actually is biochemistry. So I studied biochemistry in university. I can tell you a lot about soft corals and their stress and their mediators and prostaglandins and eicosanoids and mass spectrometry and stuff like that. And I have never gotten paid for any of that. So, but I am getting paid for IT for some reason. Now, okay, maybe I'm at like the exception here, but let's talk about my course for a moment. There's a guy whose name is Silver. He quit in the middle of bachelor's to work in IT. Okay, so it's two. Then there's, what was his name? Ardo. Ardo quit right after bachelor's. He got his degree and he started working in IT. All right, okay. Then there's me. I got my master's and I started working in IT. And of course, there's the Estonian student thesis competition winner. Let's see if the internet is still working. Yep. Winner from last year, the best PhD thesis of 2018, Katre, who studied nanotoxicology, who got the degree, and if we go to LinkedIn, then yes. So my estimate is like there were something like 30 of us graduating, more than 10 of us are working in IT, and less than 10 are working in actual chemistry. What do we make of this? Chemistry is a colossal waste of time.
Chemistry industry is very sad in Estonia.
Yeah, it's hard in Estonia, and it's probably not very easy in other places as well, but in IT, it's the other way around. So how can we help people from not wasting their and university's time and making the right decisions right from the get-go? In addition to my day job, I have a side job at the local high school teaching programming, not chemistry. And that is the way I'm trying to help young people not make the same mistake I made. So, and you can also do that as well. So, you could give courses in IT for high schools. They are always looking, at least in Estonia, for good IT teachers. There's a serious lack of, well, many real topics teachers, but especially in IT. But like giving a whole semester, that is quite a challenge and quite an undertaking, and like you have to really know what you're doing. Like it's a risk. But if that's a bit too much for you, then you can also do like simpler things. Like you don't have to give the whole course at the same time. Like that's me here. So you don't have to give the whole course, but you could just like offer to give one lecture at high school. The teachers and schools are always looking for like people from outside to come talk about what they actually do and like how life is in like after school. So if you contact some school and say, hi, I would like to talk, they will quite likely accept you. Then there's the second option is that so that the kids will actually understand what's going on, invite them to your offices, show them around, show them that you're actually normal people. You're not Bill Gates or Mark Zuckerberg. You don't have to be like mega geniuses to work in IT. And of course, the last one is become a teacher. That is all. Thank you.
Thank you, Ken. Can I have the next speaker? Thank you.
Okay, hello everyone. I actually had the talk during lunch, but because not many people were there, I decided to give it in the form of lightning talk. So if somebody was there, I sincerely apologize for wasting 5 minutes of your time. You can just fall asleep for those 5 minutes. And the things I will be talking about, first of all, I work for Microsoft. I used to be an evangelist for 10 years. I liked developing in C# and F#. And then for the last 2 years, I switched to being a data scientist and doing machine learning in Python. And that was a really difficult thing to do. Because at first it was like, switching to untyped language, it was very difficult. And besides being untyped, there was another thing. Like I used to write data processing in F# in this way, like shown on the left. This is the sample how to calculate the frequency dictionary of a text file. So you can see that it starts with basically reading the text line by line, and then it's a kind of data pipeline, right? It's a pipeline operator which basically supplies the argument to the next function, and the whole data processing becomes really neat and understandable. In Python, if you think how to do that, like if you're a normal Python developer, probably you would write something like this. Which I guess it's a little bit less clear. My talk basically is about how to start loving Python by developing your own library to use it. And I will show the demo. I have the link if you want to later on have a look. I will probably tweet it and hope that the conference Twitter will retweet me and you will all get the link. So first of all, the pipeline operator. It turns out that there are a couple of projects which introduce this pipeline operator in Python, and the most notable one is Pipe by Julian Pollard. It allows you to write a Python code like this, like on the left. It overloads this operator, and thus the pipeline becomes very similar to the pipeline in Unix. Indeed, that's very useful, but suppose in most of the real world examples, you need to pass several values through the pipeline. So in machine learning, for example, we had a lot of projects dealing with videos, and we took the original video, and then we needed to extract a set of features, then extract more features, and put all of that into a neural network. So to do that, we basically need many values to kind of go through the same processing steps. And we came up with the idea of using the dictionaries for passing the value through the pipeline. Not ordinary dictionaries, we developed a kind of more powerful dictionary on steroids called mDict, which supports lazy field evaluation and other tricks like that. But in general, together with the pipeline operator, it allows you to write the Python code in this manner. So it starts with some kind of data producer, which is, in this case, like get files. This code, by the way, takes the set of pictures from a directory and prints the date on top of each one. So it starts with some kind of source, and then the main thing is apply operator. It takes a named field sort of from the dictionary and calculates another field in the pipeline. So you only, most of the time, you deal with like enriching this original data pipeline with new and new features. So the library which supports this is called mPyPI, and it's available on GitHub. It's available by pip install, so you can have a look at it. And just as some fun exercise, to encourage you to actually go and have a look at it, I provide an example of creating nice pictures like this using the mPyPI library and a magic thing called Face API, which is the Microsoft service in the cloud, which allows you to extract information from the image of the face. Information like age, mood, and also the facial landmarks, the points in the face. So the way you can create pictures like that is basically to take a number of pictures and align them so that you have eyes at the same points, and then it becomes, looking like this. So the code is available on GitHub. It's available also in the Asia Notebook. And for those of you who haven't seen Asia Notebooks is the free Jupyter notebooks in the cloud, which are kind of nice because you can organize the collection of notebooks in the library and then share the whole library. It's very useful for the presentations like this. So feel free to have a look at the code. The code shows how you can also create like the pictures of yourself looking pretty like this. And if you create something nice in there, please share on Twitter, share with me. I would be glad to have a look. So the takeaway, pip install, look at the GitHub and explore. And let me know if you want to chat more. I will be available for the book. Thank you.
Thank you so much. Can I please have the next speaker?
You remember me? So I just talked about visualization and showed you my GitHub repo. If you go there, there are also a couple of other crazy projects. So the visualization is actually quite useful, I think. But other ones I started with, I was reminded by Travis in his keynote. I worked on something that I didn't even remember I worked on. It's called Pava. And if you know Jython, I'm trying to find it here, yeah? So if you know Jython, it's Python running on the Java virtual machine. This is Java running on the Python virtual machine. And the way it works, I broke my ankle and I was laying in bed and I was bored and I wrote this. So it basically takes Java code like package hello world and it turns it into Python. And then it runs on the Python VM. How useful is this? I have no idea. But I thought it was cool to build. The other one is called Icograph. It's just a little bit more useful. You would really want to try this out if you work in a company that uses Google technology. This renders a really cool picture of your connection graph with other people in your company. If you want to see a live demo, come afterwards. I don't want to show my work graph at work on this thing here, but do come back. And the other thing I really want to show is called Augur. So the previous one I showed you visualizations, and it uses sys.settrace to visualize the execution by setting a breakpoint and drawing pictures. This one remembers everything that happens in the program. So if you are interested in writing a unit test for a particular class, like say the class foo here, you create an instance of foo and then you call some function on it. What sys.settrace does, it looks at the stack trace of everything that is happening all the time, and it looks at this class and see if the class is somewhere in the middle, like where did you come from and what are you calling to the bottom. So the things at the bottom become mocks automatically, and the things that you call into, it remembers all the types and the values of the things that go in. And then the output is a fully working automated test. So you don't have to write unit tests anymore. Yeah! You just run Augur, and it writes all your tests. Awesome. What I was thinking of as well is if you bind this up with mPyPI, then you can remember all the types and automatically update all your source code with the right type hints as well. So maybe that's, I've got to break my other ankle. Anyway, that's it. If you want to see a live demo of anything, just come after. I'm here. Bye-bye.